This is the International AQA certificate for GCSE, and we're looking at environmental change. In the last video about adaptations, we were looking at some of the key features that organisms have acquired over their lifetime of existence, whereby they are adjusting to their environment that they live. That may be an increase in temperature, it might be putting up with strong water flow, all sorts of different adaptations that exist. What we're going to look at here are some of those changes that can take place and the effect they can have on all the organisms that live within that ecosystem. We're then going to go on to look at some of the ways in which we can measure that information and think about the impact that could have for the ecosystem within itself and ultimately ourselves on the planet. When thinking about an ecosystem and the things that live within it, we divide the populations of different species up into different groups. So in the same way that there's a community that lives in a town, or we in a school are quite an enclosed community, that community is all the different living species within it. Okay, so regardless of what they are, but every organism living together. And within that community, we measure each species as a population. So you may have a population of ants, or you may have a population of a particular type of bird. Those are the total numbers of that particular organism. All of those different species must interact together. We all live in supposed harmony together, therefore we have to tolerate each other, we have to find our own food sources, find our own shelter, etc. And these are some of the factors that we're going to come to consider, and that's what we looked at in the last video to do with adaptations. What things do organisms compete for? So mates, food, shelter, space, and so on and so forth. So in terms of the changes that can take place within an environment, there's a huge array of factors that can cause those changes. They could be to do with the actual community itself. Maybe the certain numbers die off. Maybe there's an introduction of a new species. All of these things are going to add a new pressure for the already existing organisms to exist under. A new food source might mean more organisms can survive. Maybe a new predator would mean that less can survive. But we've also got to consider other factors that are taking place, and global warming is one of the key issues in our world at the moment, primarily caused by humans and their activities. And the knock-on effects of those can be catastrophic. If sea temperatures are rising, then the change in temperature can be damaging to the fish, because maybe their food that they eat can't survive in the change in temperatures, they're not adapted for it, and therefore those numbers die. The knock-on effect down the food chain is going to be very major as well. Perhaps the changing sea temperatures might affect something like migration patterns of whales. If temperatures are changing in the waters, it might encourage them to move at different times of year or go to places where they would never have ordinarily gone because the temperatures are more suitable for them. Perhaps the feeding sites, whether it be for birds, whether it be for animals in the water. If temperatures are changing, again, they might encourage animals to take one residence in one place over another. The key example you need to know in your specification for the International AQA GCSE is looking at something like bees. The UK bee population is currently under threat, and the consequence of that is much bigger than you or I probably actually appreciate. For many unknown reasons, but also the assumption and expectation is that it's due to air temperature changes as well, linked with global warming, the numbers of bees are rapidly declining. Now we know that bees, particularly the honeybee, is essential in the pollination of certain crops. Now these crops are ones that we rely on for our staple diets and foods, so production of wheat and so on and so forth. And without these bees, for many of these crops, they are the sole pollinator. And therefore there's going to be no pollinating of those crops, and therefore that staple food is going to die out. Similarly with apple trees are simply under threat because of the decline in certain types of bees. But that's not just a problem in terms of the food supply. The knock-on effect of that goes further than that. Without the crop, the economy is going to struggle, and therefore, as a result, a nation is going to struggle. And the impact on humans has been rated to say that if certain bees were to die out, humans might follow within about 5 to 10 years after that as a result. So the change in environment needs to be monitored, needs to be controlled if bees are going to survive and ultimately looking after ourselves. Another named example in your syllabus is looking at birds, and the changes in temperature around the globe are affecting the migratory patterns of birds. And again, the migration itself may not necessarily be a problem, but it's the knock-on effects of all of those that are. So if birds are stimulated to migrate by sudden changes in temperature and daylight hours, etc., whilst the daylight hours may not be changing, if the temperatures are warm enough, they'll be encouraged to stay. Their food, the insects they eat, may still be around, so there's no need for them to fly elsewhere. That's great. Well, it could be great for our population, our country, but what about the other countries where they should be flying to? Those countries and those ecosystems might be expecting the arrival of certain birds. Maybe they're bringing food sources or getting rid of other insect populations that might be too great at certain times of year. If the migration's not happening, well then there's a major knock-on effect, not just in one country, but potentially across the globe, wherever this migration may take place. All of that puts different competitive pressures and selection pressures on those other organisms, and that could ultimately lead to organisms with different adaptations being able to thrive in their own right, or indeed die out as well. So, things that can affect the environment is another area of our focus, and we divide factors affecting the environment into two categories: those that are living and those that are non-living. Living factors we describe as being abiotic factors, and non-living factors are abiotic. Sorry, living are biotic, non-living are abiotic. So examples of living factors, these biotic ones, are typically other organisms, so plants and animals. Obviously they're the things that are alive. Organisms that are of the same species, they're all in competition for the same thing: food, mates, space to live, so on and so forth. And because it's the same species, we call that intra-specific competition. Just like the intranet is within our school, the intra-specific competition is within a species. Similarly, in a whole ecosystem, there are lots of organisms competing for potentially the same food, or certainly space and potentially habitats. So that should be inter-specific competition, not intra. Inter-specific being different species. Predators, prey, they're all living things. Introducing new predators, we've already said, you can affect the distribution of organisms in a population. Coming across to this side, the non-living factors, the abiotic factors, you can see the list here. Fairly typical sorts of things that might affect it: light intensity, temperature, pH, so on and so forth. All of those different things will affect the ability of organisms to survive. What we can then do as scientists is to go in and measure each of these to gain an impression of how things are changing over time and what effect that could be having on the population and an ecosystem. So, how to go about measuring these changes? Measuring the non-living factors, those abiotic factors, is relatively straightforward. If you want to measure the pH, you'll stick a pH probe in. If you want to measure temperature, you'll put a thermometer in. We can use wind gauges, rain gauges, oxygen probes, carbon dioxide probes. We can name pretty much anything, and we'll find a way to measure those abiotic factors. Measuring tools have lots of advantages and disadvantages that need to be evaluated. And don't forget, in questions, evaluation means looking at the pros and cons, the advantages and disadvantages of each. So we have to consider things like how accurate the tools are, and being a modern scientific tool, they can be relied upon to be relatively accurate. You can use them lots and lots of times, get the same result, for giving you lots of reliability as well. However, measuring abiotic data light intensity or oxygen temperature, they are only measurements at that specific time of day or year. And it doesn't give you an impression of what would happen over the changing season or even multiple years. So you would have to come back regularly and take multiple readings in order to gain a more accurate value. Even light intensity can vary minute by minute as the clouds blow past the area in which you're working. So some key considerations to give to any equipment that you happen to be using or asked to use in an exam question. Looking at living indicators, well, this is something that's a little bit trickier, but can be relied upon very well. Examples of things we might look at might be air quality, and for that we could look at lichens as an example. Just to show you a quick picture of some lichens. These are the things you see growing on maybe the bark of trees or the roofs and walls of buildings, etc. Here we've got a tree trunk with some white lichen and yellow lichens and some green lichens and mosses, etc. These are all very, very sensitive to particular elements within the air. And so the yellow ones are particularly sensitive to sulphur, for example, or the white ones maybe for nitrogen. And so if the air quality was to change, that could mean that you would suddenly see a loss in one type of lichen and an increase in another. And these can be really, really good tools as an indicator of how the air quality happens to change over successive time. And all we can do is go out and sample these and without actually needing any digital equipment. Moving back to this, we could look at water quality, and again, the freshwater invertebrates, so those little insects, etc., that live in water, freshwater streams like rivers, as opposed to the salt streams, salty waters. These are really, really good indicators of the quality of that water. Some of them absolutely love the cleanest water possible, really high oxygen content, nice neutral pH, and so on and so forth. Whereas other freshwater organisms actually love really dirty water, so freshwater hoglouse, for example. That would be found in dirty, polluted water. And so it's not always a case that just because there's a high number of organisms that there's a high quality of water. Different organisms like different qualities and therefore might be more suitable in different environments. Bacterial colonies, again, some grow in different temperatures better than others, some like different water quality. So all of these organisms are suitable measures of water quality. So in order to collect the data, it's probably worth you just looking up on any YouTube channel about each of these different techniques. So collecting rainwater in buckets, and not only do you get the volume and amount per day or week or whatever, but you can also analyse the quality of that for acidity and number of particles of carbon that happen to be dissolved in it, therefore giving you a really good idea of what's happened to the air quality over a period of time. Measuring temperatures is fairly straightforward. You need to have a look at kick sampling in rivers. There's a clip in your notes that we've given you that you could look up, and you can simply search for any others. This is the technique that you would use for collecting freshwater invertebrates in these rivers. And similarly, we've talked about percentage cover of lichens with a mini quadrant onto a tree or a wall as a source of air quality. So a few things for you to look up as well. They need to be able to describe the advantages and disadvantages of each of these measuring systems. Do they show you what you want? Can you apply it to measuring your numbers of invertebrates or organisms that you're concerned with in that particular environment? And what we're going to look at the next video is how we can go about sampling the numbers of different species where they live.